Lechatliers principle. In this lecture, I will teach you my personal trick of Lechatliers principle. I challenge you that you will not find this trick in any book or in any video format. So watch this lecture till the end and you will learn something very easy about Lechatliers principle. Firstly, let me teach you the easy concept of chemical equilibrium. Let's consider an atom X and an atom Y. Now X and Y atoms react together to form XY molecule, while this XY molecule breaks down to form X atom and Y atom. So this is a reversible reaction. Lastly, when the speed or rate of forward reaction will become equal to the speed or rate of backward reaction, this stage is called chemical equilibrium. Hence, this reaction is in chemical equilibrium because the speed of forward reaction is equal to the speed of backward reaction. Here, let me ask you one important question which I often ask. What is meant by disturbing chemical equilibrium? Well, when we say disturbing chemical equilibrium, it means that we are disturbing or changing the speed of either forward reaction or backward reaction. So remember that whenever I say disturbing the chemical equilibrium, it means that I am disturbing the speed of either side. Now the second question is, how can we disturb the chemical equilibrium? Basically, there are three methods through which we can disturb any chemical equilibrium. Firstly, change the concentration of reactants and products. Secondly, changing the temperature of a system. And thirdly, changing the pressure of a system. Thus remember that we can disturb the chemical equilibrium by three different ways. Now what is Lechatliers principle in simple words? Well, consider the previous example. Let this reaction is in chemical equilibrium. Now I am interested to disturb the chemical equilibrium. Let's consider that I add one another atom of X and one another atom of Y. So I have changed the concentration of reactants. Now this system will respond to this change of concentration of reactants. Let me repeat it. This system will respond to this change of concentration of reactants. Here, the change is simple. I mean, the concentration of reactants is large and the concentration of product is small. So what will be the response of this system? It is very simple. The rate of forward reaction will become high to make more products. Now the rate of forward reaction is higher than the rate of backward reaction, or we say that equilibrium is shifted in forward direction. Lastly, when two molecules are completely formed, the system will restore its chemical equilibrium. I mean, the rate of forward reaction becomes equal to the rate of backward reaction because four atoms react together to form two molecules and two molecules break down to form four atoms. Now listen carefully. Overall, we learn that if we disturb the chemical equilibrium of a reversible reaction, it will respond to the change and will restore its chemical equilibrium. Let me repeat it. If we disturb the chemical equilibrium of a reversible reaction, it will respond to the change and will restore its chemical equilibrium. This is what the Lechatliers principle states. So note it down this super easy definition of Lechatliers principle, which is often made very difficult. Now let me teach you my personal trick of Lechatliers principle. For example, consider these reversible reactions. Now what will happen if we increase the concentration of hydrogen gas in this case and decrease the concentration of nitrogen gas in this case? Well, I use my personal trick. Let X atom and Y atom react together to form XY molecule and XY molecule breaks down to form XY atoms. Now listen carefully. When we increase the concentration of hydrogen gas, it means that we are adding more hydrogen gas. Here, if I ask you what is changed, your answer is simple. There are more reactants and less product. Secondly, if I ask you what is the response of this system, your answer is again simple. The equilibrium will proceed in forward direction to form more products and neutralize the effect of concentration. Let me repeat it. The equilibrium will proceed in forward direction to form more products and neutralize the effect of concentration. Therefore, remember that if we increase the concentration of the hydrogen gas, equilibrium will shift in forward direction to neutralize the effect and restore chemical equilibrium. Secondly, I again write X and Y atoms. They react together to form XY molecule. Now listen carefully. When we decrease the concentration of nitrogen gas, it means that we are reducing or removing nitrogen gas. Here, if I ask you what is changing and what is the response of the system, your answer is simple. There are more products and less reactants. Secondly, the equilibrium will proceed in backward direction in order to form more reactants and neutralize the effect. Therefore, if we decrease the concentration of nitrogen gas, equilibrium will shift in backward direction to neutralize the effect and restore chemical equilibrium. Thus, using this trick, we can easily calculate the equilibrium shift if concentration is changed. Now let me teach you the effect of changing pressure on chemical equilibrium. Here, remember that changing pressure only affects reversible reactions if reactants and products are in gaseous state. Now consider these reactions. What will happen if we increase the pressure in this case and decrease the pressure in this case? Well, on the left side, there is 1 mole of PCl5, while on the right side, there is 1 mole of PCl3 and 1 mole of chlorine gas. So I write 1 mole of reactants and 2 moles of products. Now here, the trick is that we only consider larger number. We can see that the larger number is 2 mole. Now listen carefully. When we increase the pressure, it means that we are increasing the number of 2 moles further and putting more pressure. Let me repeat it. When we increase the pressure, it means that we are increasing the number of 2 moles further and putting more pressure. So here the change is more pressure on products and less pressure on reactants. Can you guess the response of this system? Well, it is simple. The equilibrium will proceed in backward direction to counter the effect of pressure and restore chemical equilibrium. Secondly, in this case, we already know that there is 1 mole of reactants and there are 2 moles of products. We know that we only consider the larger number. Here, the larger number is 2. Now when we decrease the pressure, it means that we are decreasing the number of 2 moles further and putting less pressure on reactants. Let me repeat it. When we decrease the pressure, it means that we are decreasing the number of 2 moles further and putting less pressure on reactants. So here the change is less pressure on products and more pressure on reactants. Thus the response will be the equilibrium will proceed in forward direction to counter the effect of pressure. Therefore, remember that decreasing pressure means that equilibrium will shift in forward direction. So using this simple trick, we can easily calculate the effect of change of pressure on chemical equilibrium. Here, let me teach you one bonus question. Consider this reversible reaction. What will be the effect of increasing or decreasing pressure? Well, the answer is simple. Increasing or decreasing pressure has no effect on this chemical reaction because the number of moles of reactants is 2 and the number of moles of products is also 2. So note it down that if the number of moles of reactants is equal to the number of moles of products, changing pressure doesn't affect the chemical equilibrium. Finally, let me teach you the effect of changing temperature on chemical equilibrium. Remember that if heat of enthalpy del H is negative, it is an exothermic reaction in which heat is given off to the surrounding. While if heat of enthalpy del H is positive, it is an endothermic reaction in which heat is absorbed from the surrounding. Now consider these reversible reactions. What will happen if we decrease temperature in this case and increase temperature in this case? Well, we know that this is endothermic reaction. In case of endothermic reaction, I always write here cold and I write here hot. Here, the trick is we only consider the hot side and we do not look at the cold side. Now listen carefully. If we decrease the temperature, it means that we are cooling the hot side or removing heat from the hot side. Let me repeat it. If we decrease the temperature, it means that we are cooling the hot side or removing heat from the hot side. So the change is product becomes cold and reactants become hot. Now the response is equilibrium will proceed in forward direction in order to produce more reactants to counter the effect of temperature. Secondly, in this case, we know that the enthalpy of heat is negative, so it is an exothermic reaction. In case of exothermic reaction, I always write here hot and I write here cold. Now listen carefully. If we increase the temperature, it means that we are adding more heat to the hot side. Let me repeat it. If we increase the temperature, it means that we are adding more heat to the hot side. So the change is reactant becomes hot and products become cold. Thus the response of the system will be equilibrium will shift in forward direction in order to produce more products to counter the effect of temperature. Therefore, if we increase the pressure, the equilibrium will shift in forward direction. Thus note down these examples. Lastly, let me teach you one bonus question. Why adding catalyst cannot affect the position of equilibrium? Well, it is because the catalyst speeds up the forward and the backward reaction to the same extent. So adding catalyst only speeds up the forward and backward reaction. It doesn't change the position of equilibrium. I hope that you have learned all about Lechatliers principle.